Today I'm thrilled to share a project that's incredibly personal to me. If you follow EI, you've already met my plant. But for the newbies, meet my money plant, a gift from someone special. I've been nurturing it like a pet, pouring my heart into its care. Coming from a farming family, I grew up treating plants and trees as living beings, part of our family. But here's the problem. I'm about to leave for a 2-week trip this summer and I can't take my plant with me, leaving it without water for so long. That's a scary thought. This fear comes from a painful memory. Back in 2020, I had another plant I cherished just as much. When I had to travel, I entrusted it to a friend to water. But when I returned, I was heartbroken to find it had died from thirst. My friend forgot to care for it, and I took it personally, like I'd failed a family member. That loss lingered, and I didn't dare get another plant until this money plant came along. Now, I'm determined to keep it thriving no matter what. So I looked for solutions. I tried the classic hack, a water bottle with a hole in the cap placed upside down in the soil. But it didn't work because the soil clogged the hole and the water stopped flowing. It wasn't reliable. Then I remembered my college project, a smart irrigation monitoring system that successfully grew tomatoes and chilies on half an acre. That system was for hundreds of plants and featured a drip irrigation system. But I only have one now. So I decided to scale it down, upgrade it with modern tech, and create something perfect for my money plant. Let me walk you through my creation, the LeafGuard. I built this system to ensure my money plant stays hydrated, even if I'm away or the power goes out. The heart of the system is a NodeMCU ESP8266, paired with a soil moisture sensor and a relay to control the water pump. To make LeafGuard even more reliable, I added a provision to mount two 18650 Samsung cells and a charging circuit. This ensures that even during a power outage, my money plant gets water. It's my way of showing how much I care. My plant deserves that extra layer of protection. A voltage divider with 10 kilo ohms and 33 kilo ohms resistors lets me measure the battery pack's voltage. A key challenge was reading both soil moisture and battery voltage with just one analog pin, a 0. I solved this by adding a CD4051BE multiplexer using pins D2, D3 and D4 to switch between inputs. This way I can monitor both the plant's needs and the system's power health, all through one pin. I designed the PCB in Altium Designer, keeping it compact for one plant. Here's the schematic diagram and PCB layout file. Altium Designer streamlines every step of the electronics design process in one unified platform. With over 35 years of continuous innovation, it's the most widely used PCB design solution in the world. I've been using Altium Designer for both personal and professional projects for several years now. Altium's mixed simulation technology, built on improved SPICE algorithms, enables designers to digitally test circuit performance across all operational conditions without physical prototypes or expensive equipment, delivering comprehensive analysis, measurement, and visualization capabilities that make electronic design faster, more cost-effective, and significantly more reliable than traditional experimental methods. Altium 365 seamlessly connects everyone, from mechanical designers to manufacturing specialists, in one cloud-based platform, streamlining your electronics design journey from concept to production. There's more good news. If you're interested in trying Altium Designer, you can get a free trial and 25% off. Avail it by signing up here. The link is in the description below. The code is where the magic happens. I programmed the NodeMCU to read soil moisture from pin A0 every few hours, but for the demo, I've switched it to seconds. If the soil gets too dry, below 20% moisture, it triggers the pump for exactly 3 seconds. Why 3 seconds? I tested different durations, and 3 seconds delivers just enough water to keep the soil moist without overwatering, which could harm my plant. I also added Wi-Fi connectivity to monitor moisture levels and pump status remotely via a simple app. Now let's see LeafGuard in action. Here's my money plant, the 5-liter water container, and the LeafGuard system. Let's take a closer look at the LeafGuard system. Here, we have a water pump submerged in the 5-liter water container that can pump water through this pipe. Next, we have a sensor that senses the soil moisture percentage and sends this information to the NodeMCU in the LeafGuard system. This system is powered by an AC supply with a 5 volts 1 amp charger, which charges the battery cells inside the LeafGuard system. Then comes the app, which beautifully shows the soil moisture percentage, battery percentage, and the motor state, whether it's on or not. To simulate a dry condition, I'll lift the sensor. As soon as I lift it, the motor activates, pumps water for 3 seconds, and turns off automatically. When I place it back, you can see the soil moisture percentage has been updated instantly. LeafGuard isn't just a project, it's my commitment to my money plant, my pet, my family. With its smart irrigation, battery backup, and remote monitoring, I can travel worry-free knowing my plant is cared for. If you want to build your own LeafGuard or scale it up, drop a comment and I'll share the code and schematics. Until next time, keep your plants thriving and stay green.